Hello Math 130 students. We are going to continue lecture on page 5, section 1.2. So this section is about introducing the students to problem solving. So here are the steps that you can take for problem solving. You can read and reread the problem, assign variables or labels or pictures for unknown quantities, write a math equation, solve the equation, then make sure that you actually answer the original question and whether or not you need a complete sentence. Okay, so some of these symbols are going to be familiar. So addition here, right? The sum of 4 and 7 would be 4 plus 7. So we're talking about addition, and we know it's a sum, right? And we know that we're just adding things together, okay? All right, and we have our subtraction. And our subtraction, we know some keywords are going to be difference, less than, subtract from, and here are some of the examples, and we know that it's going to be subtraction in these cases. In this particular row, I would really want to pay attention to this, where it says 3 less than 7. So if you look at this order, notice how the 7 is here. It comes after the 3, just, looking at it from left to right, but then when you actually write it in symbols, you write it in the reverse order. So write in inverse, or maybe not the word inverse, but let's say reverse order. So that happens with the 3 less than. So whenever you see that word less than, that tells you to reverse the order. Notice how 9 decreased by 11. That keeps the order. The 9 came first verbally, so it's written for symbolically. And also for that last one, subtract 7 from 12. Well, here 7 comes first, but because I have these groups of words, subtract 7 from another number, then here you also reverse the order as well. So subtraction can be tricky, in particular because of those two. So less than, reverse the order, and subtract from, you're going to reverse the order. And then the next row that we have is multiplication. In multiplication, some of those keywords are product, times, or of. In particular for word problems, you're going to see of a lot. And you just know that you're just going to be multiplying for the most part. Now, the next row is going to be our subtraction. So whenever you see the words in a word problem, quotient, divided by, split evenly, half of, or even just a fraction written out, then you know that you're thinking about division. So you can think about it as either a fraction or what comes first, right? The quotient of 12 and 5. So notice how 12 came first, so 12 is listed first before the division sign. And that's going to be true for everything. So 14 divided by 7, then you write out 14 divided by 7. Okay, so let's go on to our first example. It says Drake spent $6.25 on 5 sticker books to give his nephew. Find the cost of each sticker box. So let's visualize what's going on here. So what he did is he bought, 5 sticker books. So you're saying, okay, so if I have that, I have 1, 2, 3, 4, 5. So 5 of those cost $6.25. So another way to think about it, if you're counting it, there's 1, 2, 3, 4, 5 of those. So you can say 5 times your box is equal to $6.25. But what goes inside the box is going to be the individual cost, the cost of each sticker box. I don't know what that is, so let's refer to it as x. So now my equation is 5x is equal to $6.25. So I am going to divide by 5 on each side. So hopefully you have your calculator nearby, and you can plug this into your calculator. 6.25 divided by 5, and you get a 1.25. So the cost of each sticker book is $1.25. So since we started with dollars, we want to make sure that we answer in dollars, okay? All right, so now for number 2. It says 3/5 of the members of the school choir are women. If there are 24 women, what is the total number of choir members? So here, it might be kind of nice to visualize what's going on. So we have 3/5 of the total members. So here, the of, if we're thinking about it as our buzzwords, that tells us to multiply. So we're going to be multiplying two things together. One of the things that we multiply is going to be 3/5. So we have 3/5, and it's going to be multiplied. So there's my multiplication symbol. I don't like to use x as multiplication because then you think it's the variable x. So I use a dot to represent multiplication. And it says, right after of, the members. So am I talking about the women in the choir? Am I talking about the men in the choir? Am I talking about total members? Members can be women and male. So here, members, and specifically, are both female and, or women and men. So this is everyone. So this is going to be total. So let's give that my T. So the 3/5 of the total amount of people in the choir are, and the R you can think of is as your buzzword. So that's going to be equals is, and it says women. So okay, well this is going to be my amount of women. Now let's see if it gives us any more values. So I still have the 3/5. Let me write that a little bit nicer. 3/5, okay. Multiplication. And what I'm going to multiply is a T value. And I have equals to the amount of women. Well, if we keep reading, it says if there are 24 women, what is the total number of choir members? So it's telling you how many women you have. You have 24 of them. So here, what is? So what is this is your goal. You want to answer this question. And the question is asking you the total number of choir members. So total. That's going to give you your T value. So now you can think of it as you have 3/5 T is equal to 24. So to get the T isolated, you are going to multiply by the reciprocal. So that's going to be 5/3. And when you do this, you are allowed your graphing calculator if that helped you, or a non-graphing calculator. And so when you do the multiplication, you will get that T is equal to 40. So then the total amount of people in the choir are going to be 40 members. And here we talk about members being everyone, so that's going to be both your male or your men and your women. Okay, so now number 3. It says Jose pays $16.20 in rent every month. This amount is $120 more than twice what his brother Jerome pays for rent. What does Jerome pay for rent? So okay, so if I'm visualizing this this word problem, maybe you want to draw a picture. So I am not the best drawer, but let's think about that. So we have Jose. So like I said, I'm not the best drawer. So there's my Jose. And he has a brother. His brother is Jerome. So 2 brothers, Jose and Jerome. How much does Jerome pay for rent? Well, I know that Jose is going to pay $16.20 in rent every month. So I know that Jose, oops, let's keep that green. What he pays is going to be that $16.20 every month. And it says that this amount is 120 more than twice what his brother Jerome pays for rent. So let's try to translate this sentence into an algebraic equation. So this amount represents Jose, which is 1620. So I'm going to have 1620. Then it has the word equals there. So that's equals. Is means the equal sign. And 120 more than twice. So let's think about what this says here. It says that it's 120 more than twice what his brother Jerome pays. And remember, his brother Jerome, let's call him J for Jerome, okay? So I have 120, and then more than, that's going to be addition, right? If something is more, then you're adding to it. So I have more. And if I have the word twice, that's going to be 2 times something. So in this particular case, I'm going to have 2 times what his brother Jerome pays for rent. So now I really have the equation 1620 is equal to 120 plus 2j. So to get the j by itself, to figure out how much Jerome pays in rent, then I am going to subtract 120 from both sides. Your goal is to isolate the j variable. So if I have 1620 minus 120, I get 1500 is equal to 2j. Then from here, divide by 2, divide by 2. So I'm going to get 750 is equal to my j. So what does that represent? Remember, the question that it's asking you is how much does Jerome pay for rent? So the j represents how much Jerome pays. So you can say that Jerome pays that 750 for rent. And so that's going to be my final answer. Okay, so now let's go on to number 4. So for number 4, it says Patty paid $35 for a purse on sale for $10 off the original price. What was the original price of the purse? So, okay, so, we all can go to the, the store, or we used to go to the store, the mall, right? And we always like a good discount. So we can think about purchasing items on sale. So in particular, we have this Patty, and she bought a purse. So what do we know? So I guess that can be my purse. So like I said, I'm not the best drawer, but you can just think of it as your purse. Okay. And it says that she paid $35 for a purse on sale for $10 off the original price. So now what I'm going to say is that $10 off the original price. So that off really means less, which means to subtract. Like if I were to say I took off 5 pounds, and then you would say, oh, she weighs 5 less pounds than she used to. So you subtract 5 from the weight that I had. So if I'm thinking about the original price, so I'm going to subtract 10 from the original price. So I'm going to rewrite that as a P minus 10, okay? Where the P is going to represent my original price. And over here I have my purse, and the purse, I know that it cost me $35 for the purse. So my equation is now going to be 35, because that's how much she paid for a purse, and it was on sale, so that's what she paid, is going to be 35 equals to P minus 10. So now if I add 10 to both sides, I'm going to get that the original price, P, is equal to 45. Okay, so now let's talk a little bit about consecutive integers. So what are consecutive integers? You're going to hear that a lot on the next couple of word problems. It says numbers that follow each other continuously in the order from smallest to largest are called consecutive numbers. For example, 1, 2, 3, 4, 5, 6, and so on are consecutive numbers. So one after another, right? So if I start at 15, the next consecutive number would be 16. And you can also count by even consecutive integers, so like 2, 4, 6, 8, those are all even numbers that are right after another. They're in order. And the odd consecutive, that means you're counting in order all the odds. So if you started at 1, it would be 1, 3, 5, 7. Let's say you started at, I don't know, some odd number like 65. If I was at 65, then the next consecutive odd integer would be 67. Okay, so let's think about this. The sum of two consecutive integers is negative 221. Find the numbers. So here, I know that the numbers are going to be negative because they're one after another. So what we're saying when we say the sum, I know that's going to be addition, and two consecutive integers. Well, we also have is, which is going to be my equals. So the first number, I don't know what that is, so let's call that x. So then my second number, and since it's consecutive, it's going to be 1 after that. So if you think about it on the number line, if I have, let's say, 13, then if you were to count, you would have 13, 14, 15. So if I started, let's say for example, if I just started at 13, to get to the next integer, if I had no idea what it is, how would you get there? Well, you would say it's x plus 1. So that second number, whatever it is, because I'm just assuming in that diagram that it's 13, but it could have been 5, it could have been 3, it could have been 21, right? There's a bunch of different consecutive integers, and I don't know where I exactly started. But I know that the next, so if I start at some random number, I know the consecutive after that would be the x plus 1. So we're going to be adding these two numbers together. So you're going to be adding the first number, the sum, so that's going to plus the second number, and it's going to equal your total, and that total is negative 221. So that first number, I don't know what it is, so I call that x. That second number, you're going to call that the x plus 1, and I have equals to negative 221. So now when I combine like terms together, I have 2 x's plus 1 is equal to negative 221. So then from here, to get the x isolated, subtract 1 from both sides. So that I have that 2x is equal to negative 222. So I'm running out of room, so I'm just going to slide it over. 2x is equal to negative 222. So to get the x by itself, I divide everything by 2. So x is going to equal to a negative 111. Okay. So if I'm on the number line, I would have negative 111. So just kind of visualizing that number line, I know that that first integer is negative 111. So what I'm saying to find that x plus 1, that second number over here, we added 1. So if we add, I would go in this direction. So that number would be negative 110. Because if you are going deeper into the negative, you go towards negative infinity. So then this number to the left would be a negative 112. So my second number would be negative 110. So the way that I would answer this equation or this problem, I would say that the first number, x, is equal to negative 111, and that second number, the x plus 1, is equal to a negative 110. So that's how I'm going to figure out that answer. So having negative 111 and negative 110 are the integers that when I add together, it gives me 221. So taking that same process, we have the sum of two numbers is 10. One number is 2 less than the other. Find the numbers. Well, I know that I have the word sum, so now I'm going to be adding. And what I'm going to be adding are two different numbers, and I don't know what they're going to be. So let's say we have the first number, and I don't know what that is. So let's just go ahead and read the next sentence. It says one number is 2 less than the other. Oops, sorry about that. And here the second sentence says one number is 2 less than the other. So I don't know what the first number is, so I'm going to call that x. Why not? So then my next one, the second number, I know that one number is 2 less than the other. So 2 less than, well, I know that less than is to subtract. Not only is it subtract, but it's also reverse the order. So that means the other, well, I don't know what that other is. Let's call that the first numbers. That was x. So it's 2 less than, so I'm going to have subtract 2. So here I can think of this as being the number x minus 2. This is so the second number is the number that is 2 less than the first number. The other I'm labeling as the first number. And remember, it said in the beginning the sum of these two numbers. So I have my first plus my second, and that is going to equal, and it says it's equal to 10. So the first number that I have was x. The second number that I had was x minus 2, and it's all equal to 10. So combining like terms, x plus x is 2x, and then I'm going to add 2 to both sides, so that 2x is equal to 5. Oh, sorry. I did that wrong, didn't I? Let's think about this. I went too fast and furious. What is 10 plus 2? Sometimes I have to slow my roll. 10 plus 2 is 12. There you go. So now, if I copy that out slowly without rushing, that's what happens when you rush, right? You make mistakes. So you're going to have a 2x is equal to a positive 12. Since you want the x by itself, divide by 2, divide by 2, so you can get that x is equal to 6. So I know that that first number is 6. And that second number, to figure that out, well, since x was 6, I'm going to subtract 2. So then 6 minus 2 is going to equal to 4. So now I have that the first number is equal to 6, and that second number is equal to a positive 4. Okay. Now for number 3. The difference of 6 times a number and 4 is 20. Find the numbers. Okay, so I have the word difference, so I'm going to subtract. So subtract the difference of 6 times a number and 4 is 20. So another key word here is, so that's going to be equals, and the number it specifically equals is 20. So okay, so blah blah blah, something with subtraction is equal to 20, since it says is 20. So it specifically says the difference of 6 times a number and 4. So let's think about 6 times a number and 4. So 6 times, that's 6 multiplied by some number. I don't know what that number is. And 4. So the and tells you what you're going to be doing. So it says the difference of 6 times a number and 4. So I have my subtraction, and it's subtract 4. Okay. So you can think that for our equation, we have our 6 times the number that we're not sure about, and it says the difference, so that's my subtraction, and 4 is equal to 20. So since we don't know what that number is, we can represent it just by saying it's x. So I really have that 6x minus 4 is equal to 20. So I'm going to add 4 to both sides. So that 6x is equal to 24. And if I divide everything by 6, then I get, well, since 6 divided by 6 is 1, and 24 divided by 6 is going to give me 4. So that number, that unknown number, is going to be 4. Okay. So for this first mixture problem, it says Tyrone has 930 in his collection of coins, all in pennies and dimes. The number of dimes is 3 times the number of pennies. How many coins of each type does he have? So for this particular word problem, it's a lot going on. So sometimes students like to draw a chart, and I very much encourage that sometimes, so that way it helps you organize your values, so the equation just kind of falls right out of there. So what do we have? We have pennies and dimes, and they're being combined together. So I know each penny, the value of that. So each penny is going to be 0.1 cents, right? That's what pennies are amount of. So now that my dimes, the value of that is going to be 0.10. So what else do I know? It says that the number of dimes is 3 times the number of pennies. So we're talking about the number of dimes, so I'm going to be looking inside this box. And it says is, so okay, I'm inside that box, and it says 3 times, so 3, and I'm going to multiply it by something, and that something is going to be the number of pennies. Well, I don't know what the amount of pennies are, so how about I call that P? So the amount of pennies is going to be my P here. So now my combo equation is going to come from multiplying the first 2 rows together. So I have my 0.01 times my P, and I also have my 3P, and that is going to be multiplied by my 0.10. Okay. So then from here, since I'm multiplying those 2 together, I know I'm going to be adding them, and it's going to give me my total amount. And that total amount is here. So my total amount is going to be my $9.30. So when I rewrite this equation, I have a 0.01p plus a 3p times a 0.10 is equal to 9.30. So now I'm going to multiply these 2 numbers together. I'm going to multiply 3 times 0.10. So 3 times 0.10 is going to give you a value of 0. Oops, wrong color there. It's going to be a decimal value of 0.3p. So now if I add 0.01 plus my 0.3, that gives me a 0.31p is equal to 9.30, right? So it's like saying I added 30 cents plus 1 cent, so that gives me 31 cents. So now I'm going to divide by that 0.31 on both sides. So if you have your calculator, 9.30 divided by 0.31 gives you 30. So what did the P represent? The P represented the amount of pennies. So the amount of pennies that you have is 30 pennies total. And if I want my dimes, oops, wrong color. So if I wanted my dimes, it would be 3 times P. But I know the amount of pennies. So when I enter that value, I'm going to have 3 times my 30. And that's going to give me 90. So my dimes, the total amount that I have is 90 dimes. So if I have 30 pennies, and if I have 90 dimes, then together that adds up to $9.30. Okay. Now we can do a different value. So let's, instead of pennies and dimes, let's do dimes and nickels. So Micah had $3.75 in quarters, dimes, and nickels in his pocket. So actually we have all three, quarters, dimes, and nickels. He has 5 more dimes and quarters and 9 more nickels and quarters. How many of each coin are in his pocket? So I like to start with the value because I know how much each quarter is. A quarter is 25 cents. Each dime is 10 cents and each nickel is 5 cents. So at least I wrote down the cents for each quarter, dime, and nickel. Now, in particular, it says that he has 5 more dimes than quarters. So that word than, that's going to be your point of reference. So if that's your point of reference, then quarters is what you don't know. So let's call that Q for quarters. But I know that for my dimes, he has 5 more dimes than quarters. So I have 5 more, so that's plus 5. And then that reference there is quarters. So my dimes, I don't know how many I have, but I know that I have 5 more than my quarters. Now I'm going to go into my nickels. It says, and 9 more nickels than quarters. So again, you have your point of reference. So you're specifically talking about nickels, but the thing that you're comparing it to in this particular equation is going to be your quarters. Okay? And if you have something that's more, then that's going to be addition, and it's 9 more. So you think of it as 9 plus Q, or you can think of it as Q plus 9. Okay? So everything kind of relates back to your variable quarters. So now when I multiply these values together, or make my combo, I would have a 0.25 times Q. I would have a 0.10 times a Q plus 5. And I would have a 0.05 times a Q plus 9. And it would give me my total amount. And you would add all 3 of those together, and your total amount here is your 375. So now you have your equation that you can write. So you have a 0.25Q plus 0.10 Q plus 5 plus a 0.05 Q plus 9 is equal to 375. So the first thing you need to do is distribute. So I have a 0.25Q. And if I distribute, it's going to be a 0.10Q plus, and now you have to multiply. 0.10 times 5 is going to give you a 0.5. Plus, now you're multiplying 0.05. So you're going to distribute on the inside. So you'll get a 0.05Q plus, and 0.05 times 9 is a 0.45. And it's still equal to 3.75. So now I'm going to add all of my Q values together. So what I'm adding together is a 0.25 plus a 0.10 plus a 0.05. When I do that, I am going to get, and let's do that on my calculator. Let's try that again. So 0.25 plus 0.10 plus 0.05, and that's going to give me a value of 0.4. And that's Q. Plus, and now I have those values I'm adding together. 0.5 plus a 0.45 is going to be a 95. And that's equal to 375. So from here, to get the Q by itself, I'm going to subtract by 0.95 on both sides. So I have a 0.4 Q is equal to, and I have 3.75 minus my 0.95, and I get a 2.8. So running out of room, I have a 0.4 Q is equal to 2.8. So to get the Q by itself, I'm going to divide by 0.4 on both sides. So I can have a 2.8 being divided by a 0.4, which is going to give me 7. So what does that tell you? Oops, and I did X, didn't I? Force of habit. What variable are we dealing with here? It's Q. There we go. So Q is equal to 7. Well, what did Q represent? Q represented the amount of quarters. So I know for each quarter, I have 7. I also know how much I have for each dime. So for each dime, it's going to be Q plus 5. Let me write this out as a sentence instead. Which is my Q value is equal to 7. There we go. And if I have my dimes, well, I know is Q plus 5, so now if I have 7 plus 5, that's going to give me 12. And then the next thing I'm going to have is my nickels. So for my nickels, I know it's my quarters, but my quarters is 7, so 7 plus 9 is going to give me 16. So I have the amount of quarters, which is 7, the amount of dime, which is 12, and the amount of nickels, which is going to be 16. So I hope that helps you guys when you are doing these on the homework. Okay, just a moment. This is a very long section, so I'm going to have to split this. So this would be part A, and I will be making part B video, or it will follow up on the same link. Okay, thank you guys. If you guys have any questions, please feel free to email me.